Now for the last part though, this was a little bit more involved where you had to find the standard deviation. Now if this was a normal distribution, okay, what I would suggest you do is you have a sketch of your normal distribution in the usual way. Let's say X represents this distribution. Now when you describe a normal distribution, you normally have two parameters, the mean here and the standard deviation. Well, we know we've got, sorry, I should have said variance. The variance is often denoted as sigma squared. Okay, that's the standard deviation, sigma squared. And the first parameter is the mean, often denoted by mu. But we can find out what mu is because in the box plot that we've got, okay, if I was just quickly to draw a little sketch, something like this, alright, okay, we have the lower quartile, this value was 36, and the upper quartile, this value here, was 54. Now, if you've got a normal distribution, normal distributions are symmetrical about the mean mu. And so even though this distribution might not be quite symmetrical, okay, the mean theoretically would be midway between the lower and the upper quartiles. So we can get the mean as being literally the mean of these two values. That's 36 plus 54 all divided by 2. That will give us a value literally in between these two. If you work that out, what you find is that you get 45. So that means that the mean here is 45. So I'll rub that out now and we'll have X as following a normal distribution with a mean of 45. Now the tables always work out probability to the left of any value to the right of the mean. Those tables are what we call, they come from the standardized normal distribution. That's given by the letter Z, and they have a mean of 0. So when you're looking up the upper quartile, 54, which we'll just say is about here, okay, this value here, observed value, which I'll call X, is 54, and the area to the left, you should know that the probability of getting something less than the upper quartile is 75%. Okay, so that means that this area to the left of this observed value 54 is 75%, or as a decimal 0.75. So that means that if I take this observed value, map it down onto the standardized graph, the area to the left of this Z value here, which I'll call Z1, is also going to be 0.75. Now you should know that any Z value, okay, Z is given by the observed value that corresponds to it, which is X, minus the mean, all divided by the standard deviation. So for this example, what we have is that the Z value is Z1, and it equals the observed value, which is 54, minus the mean, which is 45, all divided by the standard deviation, sigma. Now in order to find sigma, what we need to do is find out what Z1 is. And to do this, we look at the tables. Now if you've got a set of tables, what you'll most probably see is a picture of the standardized distribution somewhere near the top, having Z there, and you'll notice that they've got a line down here normally with Z there, and they give you the area to the left of any observed value. And we're looking for this area, as I say, to be 0.75. So what you want to do is look in your tables, okay, where the area, that will be the probability that Z is less than any particular value of Z, where it says in this column 0.75. Now when you look through your tables, you'll see 0.7486 as one value. That's fairly close to 0.75. And below that you should see 0.7517. Now the Z value that corresponds to this probability is 0.67, and the Z value that corresponds to this number here was 0.68. And we're looking for the one anyway that's closest to 0.75, that gives this area to the left of Z. Okay, this area here, or on this diagram, that area there. Now this is 17 units more than 0.75. This is 14 units below 0.75. So in fact, this is the closest value. So the Z value will be 0.67. That's this value here will be 0.67. So all you've got to do is put 0.67 in there equals 54 minus 45 over sigma. Well, we know that 54 take away 45 is 9. So to get sigma, I just need to rearrange this equation. So it follows that sigma equals 9 divided by 0.67. And if you do that on your calculator, what you get 13.42 and so on. And if you round that to 3 significant figures, it's going to be 13.4 to 3SF. Okay.